you can always go back to find the difference quotient for this and then apply the limit. So we've done several of square roots. So what do I have to write in order to find the derivative using the derivative function, the definition, the formal definition?
X equals the limit as h approaches 0.
F of x plus h, yes. So then we have 9 minus x minus h minus the square root of 9 minus x. And from here, we should not, I'm assuming we should not have any difficulties because we've done several of these. What do we need to do?
Multiply by the reciprocal.
Yes, so the square root of 9 minus x minus h plus the square root of 9 minus x, the square root of 9 minus x minus h plus the square root of 9 minus x. Can anyone give us the top? I'm going to write the denominator.
It would be 9 minus x minus h.
9 minus x minus h, very good.
Minus 9 plus x.
Excellent, awesome. Now I see that you see it, so it's very comforting. These two go away as expected. These two go away as expected. Do not cross out here, okay? Just write it one more time. I know it's time consuming, etc., but it's better. Okay, now I simplify. This is the second step. Remember, this is always in that same sequence. All terms without h must go away. If some terms with h go away, it's even better, but they don't have to. And the second step is this. And now I apply this operation here, and I write the final answer without copying this again. And I'm ready when you are.
It would be -1 divided by the square root of 9 minus x minus h.
I cannot write that because I'm applying the limit. I cannot do. When I apply the limit, something. Say it again.
Is it 2 the square root of 9 minus x? Because there's 2 of them.
Yes, 2 the square root of 9 minus x. Very good. And this is a derivative function of that. Good. Other questions? Is this okay? Every step? Okay, perfect. Other questions? Anything else? From anything else? I'm ready.
Sorry, can we go over squeeze room problem?
Yes. Sean, did you have something?
It was the same problem that Caitlin just selected, except it was the one before. It was a square root problem too.
Okay, I'm ready. What am I trying to do?
It was to find the derivative using the definition of a derivative of 7 over the square root of x.
Like this?
Yes.
Okay, perfect. And what was the other one, Gia?
To use this to evaluate the limit of x to the 4th power cosine.
So this was a limit?
Yes.
Okay, your problem was a limit as x approaches?
As x approaches to
From
x to the 4th power cosine 2 divided by x.
Very good. Okay, perfect. We're going to get back to this in a moment. Okay, so f prime of x, we know now there's the limit as h approaches 0. I will put the 7 outside. I don't care for it. It's a constant. You cannot do that if we have something like this. But it's a constant over the square root of x. So I can take the constant outside. It will wait patiently, I promise you. And it will not mess up my numbers. So 1 over the square root of x plus h minus 1 over the square root of x divided by h. So this is 7, limit as h approaches 0. How come that I'm allowed to do that? Because remember, the limit, of a constant times a function is the constant times the limit of the function. So this can be rewritten as 7 times 1 over the square root of x. Good. What is the next step? Can anyone say anything?
You have to get common denominators.
Very good. Find the least common denominator, which is?
It would be the square root of x plus h and the square root of x.
That's it. So obviously this one needs at the top what it does not have, which is the square root of x, and this one needs at the top exactly what it does not have. So then the numerator is the square root of x minus the square root of x plus h. So now this is h over 1, and I flip. 7, limit as h approaches 0 from the square root of x minus the square root of x plus h divided by h, the square root of x, the square root of x plus h. And from here, I'm sure you'll know how to continue. We just did one, but I don't mind continuing. We just did this. So it's the same thing. But I don't mind continuing as long as you tell me what to do.
Multiply by the reciprocal.
Good. So this is the square root of x plus the square root of x plus h, the square root of x plus the square root of x plus h. Okay, I'll copy the denominator. Please give me I'll copy the denominator. You'd give me the numerator.
The numerator would be x minus h.
Excellent. Thank you very much. Who said that?
Janelle.
Thank you. Great job. Any questions? Is everyone comfortable with everything we've looked at so far? It's not done, but I want to hear from you. Everyone okay?
Yeah.
Okay, perfect. So now, as expected, the terms without h must go away. And then h from the numerator has to go away. Don't cross it out like here. Not now. So the negative h is in the numerator. I know it's a lot of writing with this, but now I simplify. I'm applying the limit operator. Do not forget about 7 and negative 7. Can anyone give us the denominator? Of course, you're going to say the square root of x. What is left here?
Square root of x.
That's it. And what is left here?
2 square root of x.
Very good. How much is this? In general, assuming there's positive.
Square root of x times square root of x.
Because this is x. Good. Anything else?
I do have a quick question.
Yes, I'm ready.
Because sometimes I get a little confused with the denominator when it's like that. Can you just explain that part again?
H
Especially when you did the,
H approaches
I
0.
understand the x squared part.
H approaches 0. H approaches 0. An apple plus an apple. The square root of x plus the square root of x is 2 the square root of x. The square root of x. The square root of x.
Okay, thank you.
Thank you. Anything else? Other questions here? Or can we move on to the next? Oh, I'm sorry. I got the next one. So we're asked to find the limit as x approaches 2 from, is it 2?
Yes,
So this is 2?
yeah.
Okay, very good. So 2 over 2 is 1 cosine 1 radian, and this is 2. So it will be 2 to the 4th times cosine 1 radian.
does it say after the fourth, the x to the fourth?
I thought you said cosine. Did you say cosine?
No, I was just confirming. I didn't see what that said.
Oh, sorry. But maybe I copied it incorrectly. So that, yes, it's cosine. So that's the final answer. You can write as 16 cosine 1. Good. Anything else from anything else? Have you looked at the previous test? Do you have any questions on that? I mean, there are just extra problems to work on.
Yeah, from the old test, can we go over problem 4?
Yes.
Or we're satisfying all conditions.
Yeah, let me open it. I don't have it in front of me. Okay. Okay, I'm right there. I opened it. I thought I did. We want to look at problem 4. Present the graph of a function. Okay, so this is the same thing with the table. You have to put everything in a table. Is that what you wanted?
Yeah.
Okay. So let's take a look. Let me copy it. Limit as x approaches -3 from the left. Limit as x approaches -3 from the right. And then limit as x approaches 2 from f of x is infinity. Limit as x approaches 5 from the right of f of x is infinity. Limit of f of x as x approaches 5 from the left is -infinity. Then we have limit as x approaches -infinity from f of x is 0. Limit as x approaches infinity from f of x also 0. And f of 0 is 0. Okay. So we start with the table to organize the information. Make sure we don't miss anything. I will start with f of 0 equals 0. You don't have to cross it out like that. I just want to make a point. Limit as x approaches infinity is 0. And limit as x approaches -infinity is also 0. Which means y equals 0 horizontal asymptote. Then I see something happens at 3 and 2 and 5. So 2, 3, and 5. No, -3, sorry. So -3 from the left is 2. -3 from the right is 0. You can be creative and put whatever you want in here. I decided not to. It's up to you. You can. But that means that x equals -3 is a whole. Not a whole, a jump, sorry. It would have been a whole if these were the same number, either 0, 0, or 2, 2. So this is a jump, discontinuity. So these are done. Then at 2, both sides infinity, okay. I decide not to, because I can't in this particular case. Here I can, but here I cannot. So I'll say x equals 2 is a vertical asymptote. So these two, this is done. And then 5, it says from the right is infinity. From the left is -infinity. Again, x equals 5 is a vertical asymptote. And nothing in there.
How did you know -3 was a jump?
Because the left-hand side is 2 and the right-hand side is 0.
Because our numbers versus like 2 and 5, there's infinity symbols.
So the left-hand side is 2, it stops at 2, and the right-hand side starts at 0. This is at 2, and this is at 0. It must be a jump.
So if there's numbers on both sides, is it either a jump or a hole?
If the numbers are the same, it's a hole. If they are different, it's a jump. If they are the same, it's a hole.
Because I'm comparing it to 2 and 5 on the number line, and the only difference I'm seeing is we have numbers with -2, and then, I'm sorry, with -3, and then with 2, we have infinity.
But these infinities are characteristic to a vertical asymptote. If this is a vertical asymptote, it has to go to infinity or negative infinity by definition, the vertical asymptote. By, definition, the vertical asymptote has to have infinities. If it doesn't have infinities, it's not a vertical asymptote. At least one has to be infinity.
Yeah, I'm just trying to come up with like boxes and rules why something is a jump.
It's a jump because there are different numbers. This is a infinite discontinuity because there is a vertical asymptote there.
Okay.
Good. So at -3. So the left-hand side, so first I'm gonna, this is an overkill. So that means that I shouldn't be doing this again because this is already the y, this is the x-axis, so this is y equals 0, the horizontal asymptote that I'm talking about. At -3 is 2, which means open point coming from the horizontal asymptote. At -3 is 0. So it cannot, continue. I mean, it could be continuous, a constant. So this is one piece, but I'm going to do it like this. You can do whatever you want. This is the point 0, 0. Then I move on to 1, 2, 3, 4, 5. And it says it goes to positive infinity. On the other side, also positive infinity, but it drops to negative infinity. And then it's coming from positive infinity to 0. So this is my example. You can come up with every one of each and every one of you can come up with a different shape. And they may all be correct. So here is the function is undefined at this point. It's undefined at 2. It's undefined at 5. Here it has its vertical asymptotes, and here on the left is 2. The limit is 2. On the right, the limit is 3. I'm sorry, 0. On the right of -3, the limit is 0. Any questions? Anything else?